Hi, fifth graders. My name is Mrs. Greenday, and I'm a teacher at Fair Oaks Elementary School. I am very excited to be doing some at-home learning with you today. We're going to be looking at fifth grade math SOL 5.8. We're going to be working on solving some practical problems involving perimeter, area, and volume, differentiating between perimeter, area, and volume, and then identifying when we can apply perimeter, area, and volume in a given situation. In real life, we use perimeter, area, and volume as a way for us to estimate and to measure a variety of different things. Just the other day, I decided that I wanted to replace the rug that was in my dining room. Now, I already knew that the area in my dining room was 120 square feet, but I didn't want to cover the whole area with this new dining room rug. I needed something slightly smaller. So I went with something that was 7 feet wide by 10 feet long, and that gave me a total area of 70 feet squared. So it fit within my dining room, but wasn't the total amount or area of my dining room floor. And it was essential for me to understand what area was and how I could calculate area in order to find a best fit for my dining room rug. So it's something that we use all the time. Now, I know in fourth grade, you guys spent some time understanding the difference between perimeter and area. Perimeter meaning the outside edge of something. Maybe we're looking at the border of a garden or the fence around a playground. Whereas area is going to be that 2D flat inside surface. The example of the rug that I gave you fits nicely into the area category. It's a flat inside surface. In fifth grade, we also introduced the idea of volume. And volume takes us into the three-dimensional idea. We're filling something up, or we're trying to figure out how much something can hold. So the definition for volume would be a measure of capacity. How much does it hold? How much does the pool hold if I need to fill it up with water? How much does the sandbox hold if I need to fill it up with sand? That would be the measure of volume, finding that capacity. The number of square units needed to cover a surface falls into that idea of a rug. We're looking at the area, finding the area of something. And lastly, perimeter is going to be the distance around a figure. The distance all the way around the outside edge of something. Maybe we're looking at putting border up along the edge of our wall and our ceiling. That would be calculating perimeter. So I have a couple of situations that we're going to sort together just to make sure we fully understand the difference between perimeter, area, and volume before we apply it in some specific situations. So planting flowers around the edge of a deck. That's going to go in the perimeter category. It's going to go around the outside edge of that deck. Pouring water into a cylinder. It's not the outside edge. It's not a two-dimensional flat inside. It's actually a three-dimensional object, that cylinder. So pouring the water means I'm looking at the volume or the capacity, how much it would actually hold. Covering a bulletin board with paper. That's going to fall in our category of area. Thinking about that flat bulletin board, the inside of its surface is going to be our area. Distance around the pool, that's going to fall in our category of perimeter. The distance around something is perimeter. Placing a rug on the bedroom floor. That falls with my example of a rug in my dining room. I needed to fully understand area in order to calculate that correctly. And then lastly, filling a box with books. Thinking about that box as a three-dimensional object and filling it with books is going to fall in that volume category. Perimeter, that outside distance, it's a one-dimensional distance. Area is that two-dimensional inside. We're looking at the base and the height of something, or the length and the width of something. And then lastly, volume is our three-dimensional, where we have that 3D object that we are now filling up. So we're going to jump into perimeter for a quick section and look at some examples that I've given you to go along with perimeter. So if we take this triangle, for example, I know the distance on this side is 2, this side is 3, and this side is 4. To calculate the perimeter, I'm simply going to add all of those up. 2 plus 3 plus 4. 2 plus 3 is 5, plus 4 more is going to be 9. So my perimeter, 2 plus 3 plus 4, gives me a total of 9. If I'm looking at this rectangular figure here, I can see, I know that the distance along the top is 4 and along the side is 3, but perimeter is asking me to find the total distance all around. I need to think back and make sure that I fully understand that the distance on the top of this rectangle is the same as the distance on the bottom of this rectangle. So I could also list a 4 down there at the bottom. Well, if I know that the top and the bottom are the same of this rectangle, I should also know that the sides are equivalent as well. So 3 on one side and 3 on the other. To find the perimeter, I simply add up all of the sides together. 4 plus 3 plus 4 plus 3. So my equation looks as such. 4 plus 3 plus 4 plus 3. That total is a total of 14. Now, when I'm thinking about perimeter, I'm not always going to be looking for the end result. As you can see in this figure over here, I'm looking for a missing side. And I'm going to slide this down a little bit because I know that the perimeter of this object is 16. They're telling me the perimeter is 16. I'm simply trying to figure out, well, what is the missing side? I need to calculate what I already have here to find out what might be missing. And if I understand that perimeter shows me the total distance around, I can find that missing piece. 4 and 4 is going to give me 8. Adding 2 more gives me 10. And adding that final 3 gives me 13. I've used 13 out of my total of 16. So my missing side must be equal to 3. 3 is the value of this missing side here. Perimeter is simply looking at the distance all the way around. Now, area, we know, is actually the amount on the inside. So I'm going to go ahead and pull up this one so that we can quickly talk through area and perimeter before I show you something that I find kind of interesting with area. So if I'm looking at this one, I can see that I have yet another rectangular figure, and I've got 10 inches as the distance along the top, and I've got 7 inches as the distance along the side. Now, we just talked about the idea that I should know that if the distance is 10 along the top of my rectangle, the distance on the bottom of my rectangle is also going to be 10 inches. If the distance is 7 on this side, it should also be 7 on this side as well. So in order to find the perimeter, I need to add all of the sides up. 10 plus 7 plus 10 plus 7. I know that 10 plus 10 is 20. I know that 7 plus 7 is 14. 20 plus 14 gives me a total of 34 inches. Now, area is looking at what would actually fill the inside. And I can think about it like when we've used arrays for multiplication. In order to fill the inside, I would have to have rows of 10, and I would have to have 7 of those. So I'm thinking 7 times 10. In order to fill the inside of my rectangle, I would multiply 7 times 10. That gives me 70 inches squared. 70 inches squared, because this is now a 2-dimensional object. I'm looking at this inside value. So if we take what we know about area, let's see if we can apply it a little bit further. You'll notice that I have a pink rectangle drawn in here. My pink rectangle, there's a specific area that would be associated with that. 6 times 8. So I could recognize that there's 6 inches here, and 8 inches along the top. So the total area of my rectangle is going to be 48 inches squared. But the cool thing about area is that if we take our rectangular figure and we cut it in half, we subdivide it, we can create 2 equivalent triangles. If those 2 equivalent triangles add up to an area of 48 inches squared, I could think that simply the area of this triangle is half of the area of the rectangle. So to find the area of the triangle, I'm going to write it in blue, area of triangle, I'm going to take the area of the rectangle where I did base times height, 48, and I'm going to divide it in half. I'm going to find half of the value. Half of that value is going to give me 24. So the area of the triangle is 24 inches squared. The last thing that I wanted to kind of look at today is volume. And volume is that 3-dimensional measurement. So I have a box. Maybe some of you have been to a little Amazon shopping like I have. And I have a small little container as well. Both of these are objects that I am able to fill in order to find the volume. And we're going to use some of these little cubes in order to help us out. I found that this one would be a little bit easier because we could actually see how many of these cubes might fill the inside of this little container. Make a quick prediction, write it down, and then we'll start filling. I'll give you just a second. All right, I'm going to go ahead and start filling. I'll notice that as I put it in, I was able to put 2 along this side right here. Now if I turn, I can put 2 along the side here as well. So the entire bottom of my cube fits 4 of these smaller cubes. 2 times 2 gave me 4. But volume is adding another layer. I'm going to look at yet another layer on top to see how I might fill this small container. There were 4 on the bottom, and now there are 4 on the top. So volume is looking at filling this container. 2 times 2 gave me 4, times 2 layers going up. That gave me a total of 8 cubes to use to fill in my little container here. I could do the same thing with this Amazon box as well. How many across would it take? How many wide would it take? And how many layers tall might it take? So I'm not going to actually fill the whole box up, but we're going to get some numbers that could help us to figure this out. So what I'm doing right now is I'm actually lining them in, hoping to try and let you see. I'm lining them in the bottom so that we can see, okay, how many cubes does it actually take to go across the bottom of my box? I think I'll be able to fit one more in here. So that gave me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cubes along the bottom of my box. 10 cubes along the bottom of my box. Now, I'm going to see if I can put this up so that we can kind of hold on to these numbers. And it will help us to make sure that we fully understand what we're seeing with this 3 dimensions involved in volume. So it was 10 cubes across. Now I'm looking at, gosh, how many wide might it be? So I'm going to go ahead and add some more cubes going wide. What about the width? 1, 2, 3, 4, 5, 6. 6. I don't think I can fit a 7th one in there, so we're going to go with 6. 1, 2, 3, 4, 5, 6 wide. So 10 cubes long, 6 cubes wide. Trying to figure out the best way to label this. I think I'm going to label it here. 6 cubes. And then now the last part that I'm looking at is the height. How many tall do I need in order to fit the top edge of the box? So I've got 1, 2, and 3. I think this one's a hard one to see. Oh, I just dropped a bunch of them out. This one's a hard one to see. However, I was able to fit it in so that I have 3 cubes. 1, 2, and 3. So I'll label that one on here as well. It's 3 cubes with our height. Now volume being 3-dimensional, we're going to take all 3 of those numbers and multiply them together. So I'm going to take 10 times 6 times 3. 10 times 6 is going to give me 60. And then 60 times 3 is going to give me 180 cubes. In order to fill this Amazon box, I would need 180 cubes. That's a lot. So volume, remember, is looking at those 3 dimensions: length, width, and height, or base, height, and width. Whereas perimeter is looking at that 1 dimension all the way around, and area is looking at those 2 dimensions, base and height, or length times width. I'm going to leave you with a challenge problem today, and we're going to go back to area, and I'm going to go back to the example that I started with about that rug. I wanted to put that rug in my dining room. Now, I have another space in my house that I need to replace the rug. I know that the area within that space is 108 square feet. What size rug could I potentially put in there? Could you get me some dimensions of a rug that could potentially fit into the other area of my home that would not be larger than 108 feet squared? Thanks, guys, for watching today. I hope you did some great review on perimeter, area, and volume, and get some practice at home. Thank you.